All right, good afternoon, and thank you for attending this week's CAD Dimensions Lunch and Learn. The topic this week is DriveWorks Solo. So we're going to go through some of the features of DriveWorks Solo and what it can do and how it might be able to help you guys. My name is Tom DeLaura. I'm a Technical Solutions Specialist here at CAD Dimensions. And down at the bottom, you'll see some links to our new blog that came out a couple months ago, our YouTube page in case I'm talking too fast or I mumble. You can go back and rewatch this video, and our Twitter account where we're just updating you with on news and events of CAD Dimensions. All right. So what's on the agenda today? We're just going to go quick overview about what DriveWorks is, the company, what it can do, and then actually deep dive into what DriveWorks Solo can do. We'll go through creating a part and actually driving it, then going into an assembly, creating different assembly views for a drawing, and then actually using all that information to generate a quote all automatically. All right, so what is DriveWorks? DriveWorks is a design automation software which allows you to quickly and easily create and configure custom products inside of SolidWorks. So it gives you the ability to take a design that you've already created with dimensions, with features, and actually drive that to make similar yet different components and parts. It can reduce repetitive design tasks while automating the output of manufacturing documents, quotes, sales orders, and with DriveWorks Live and Pro, you can actually go ahead and integrate that right into your ERP or sales management system. So the link to DriveWorks is driveworks.co.uk. DriveWorks is a company out of England, so it's not a .com in case you run into any issues there. For the setup, DriveWorks has a tiered package like SolidWorks. So they have Express, Solo, Pro, Live, and Autopilot. Express is almost like your e-drawings. It comes standard and free with every seat of SolidWorks. So if you're a SolidWorks user right now, you have access to SolidWorks or DriveWorks Express. Solo is that next tier up, so that's your SolidWorks standard. It gives you tools to get a job done. It just doesn't go to that next step like Professional Premium has some add-on packages. So DriveWorks Pro is going to be like SolidWorks Professional, same name. You are able to have more model control, and you have the ability to float licenses across your organization. And then finally, Live and Autopilot would be like your premium package for SolidWorks. External users have the ability to generate models and automate the 3D outputs. So you can actually start seeing a model on a website. You can email that model with a quote automatically. So you're really allowing an end-user experience to design in 3D without needing SolidWorks. They're designing it using DriveWorks. So what can DriveWorks Solo do? DriveWorks works inside of SolidWorks. So like I was saying, Express comes with SolidWorks. Solo is another add-on, just like simulation. It's going to get turned on in DriveWorks or in SolidWorks, and then you'll have the ability to actually drive some features. It can create forms and drive unique configurations. So today we're going to be making many, many ratchets, different configurations, different colors, materials, all using a form that was created inside of DriveWorks. From that, we're able to standardize some manufacturing drawings. So using the information of our model, we can create a single drawing and then drive where those views are appearing, any dimensions that are in there, any notes that are in there. And finally, we're able to take all that information and create a customer-specific quote. So generating a quote, a bill of materials, or cover letter based on the configuration that your customer needs. Today we're going to start with just creating a pretty simple part. We're going to make this socket head. We're going to be able to capture that. We're going to make it in SolidWorks, capture it in DriveWorks, and then identify the key dimensions and properties that we want to actually drive to create many configurations of this part. For this one, we're going to use a table to actually identify some of those dimensions. and then I'll go through and create some rules to give you a general idea of how DriveWorks is working. All right, so let's get out of PowerPoint and actually jump into SolidWorks here. So the first thing I'm going to do is just create a new part, and I want it to be in inches. So you saw a preview of that socket head that I want to build. So it was really pretty simple geometry. We're going to start with just a round head. One important thing for DriveWorks is you want to make sure everything's going to be fully defined. While your dimension doesn't really matter because it's going to get driven in the scheme of things, you need to have that fully defined sketch in order to have a dimension that you can drive. So quickly draw a circle here, extrude it, and now we want to make our hex head on the top of this. 6 size looks good. Throw a dimension on there. All right, so even though I dimensioned this, I'm still not fully defined. I still have the ability to move this around. So all I'm going to do is add a quick relation, vertical, make sure my sketch is black, and we're good to go. So this I'm going to extrude cut. Just got one. All right, and then on the other side, I want a square fitting. So this is where my socket's going to connect to my actual handle. Get some dimensions on here. Looks good. One more cut. All right, and now all these dimensions that I'm actually cutting and extruding are recorded in SolidWorks as the dimension. So later on we can drive those using DriveWorks. The last thing here is this is kind of our connector slot where the handle is going to connect to our socket. Final dimension there, final cut. And this one we want to go through all just because as we're changing dimensions for the square and for the hex, we want to make sure that this connector is going to go all the way through the part. That looks good. Final thing I'm going to do is just throw a couple fillets to make this guy look nice. One there, we'll put one on the inside here. Great. All right, now I have a pretty generic socket head here, a hex head. So using, you see right in my task panel here on the right side, I have DriveWorks Solo. In order to get that, just going into add-ins, and down towards the bottom is another add-in, DriveWorks Solo turned on. All right, so what it's given me is little hints here to better finalize my project. So first things first, model must be saved before I can capture. Okay, I'll click that link and it'll bring up my save as. For this one, I'll go through my unorganized desktop, put it in my Lunch and Learn, put it in a final Lunch and Learn file. So this is my hex head part. So now I have the next option to capture this model. When I click that, I now have this model represented inside of DriveWorks. So if I click on my captured models, hex head exists. So for this specific project, all I have is one hex head model inside. From here, I could actually start choosing my dimensions and features. So double-clicking my first boss extrude, I get to see my sketch circle and the depth of my extrusion. When I click on that dimension, DriveWorks gives me the opportunity to rename. So instead of D1 at sketch 1, which is very generic, and I might get lost when I go to drive this, I can actually give it a name. So this is going to be my socket diameter. I'll add that, and my dimension folder starts getting populated. This is going to be my socket depth. that feature is covered. Next one, I have this hex cut that I did. This is going to be my hex diameter, which will drive the size of that hex cutout. And this is going to be my hex depth, which is the length of that cut. All right, next one is our square feature. We'll call this square length and square width. You'll notice I'm not putting any spaces in here. DriveWorks is only using, it doesn't recognize the space in a name. Oh, just kidding, that's later on. So you can, if you want to add some spaces in here, that's okay. So square depth. All right. What else? I got my connector pass-through still. So all I care about is the diameter for that. Connector diameter. And my last two fillets, I could actually drive those radiuses. Outer fillet. And I got an inner fillet here. Great. So now my fully defined model has all the dimensions that have the capability of being driven. So we're good there. We also have the opportunity to apply some custom properties. So if your parts or assemblies have custom properties, you can go ahead and insert them here so they'll be captured with the model, or you can go and create your own. So DriveWorks has specific callouts for material and, I spelled material, right? Material and color. And when you create it, it's going to recognize that and can be driven for the material and the color. So that looks good. Drawings and replacement models and file formats we'll get into in a bit. But right now, I have my generic model that I want to be able to drive. So what I'm going to do is actually open up my project designer, and we'll look at how to drive this model. All right. So first thing I want to do is add my hex head. So in my model rules, I can add a component, and that's the component I'm working on, is my hex head. When I bring that in, all my dimensions that I was playing with earlier now come in. No values are set because I haven't generated any rules yet. So what I need from the user interface is actually some information on what they want to build. So stage one, SolidWorks or DriveWorks sets this all up nicely that you go right in order. So your first stage is your user interface, where you get a form navigation. So if you have multiple forms or steps in a process to build this, if you want to start with a hex description and then go to a square description, you can do that all in different forms. We don't have that much data, so we're just going to use a single form. Clear this up. Okay, so our form design, using all these options up here, we can actually go ahead and generate a new form. What I'm going to be looking for is I need the hex diameter as my main focus here, because that's going to drive everything else in this configuration. So I can either use a combo box, or a list box, or slider. Let's start with a slider and see how that looks. So this is going to be our hex diameter. So what this does is starts off with a generic 0 to 100. You'll see on the right side again that we have some controls. So anything in green is a dynamic control that I can change this with. So for my maximum, I really only want a hex that fits up to 1.5 inches, and a minimum down to 1/4 inch. So as soon as I change this, my form's getting updated. For my increment, I'll go up to 1/8 of an inch every time. So what this gives me the ability to do, if I hit test, I can actually come in here and start playing with it. And I now have a slide rule for 1/4 inch up to 1.5. I can't really understand what I'm looking at there. I don't know what this value is. So what I can do is add a label, and we'll call this hex result. And all this is a text box, but I can drive the text inside of it. So instead of doing hex result, I can open it up. So the ... allows me to drive my rule. So instead of saying result, I want it to display the hex diameter return, so what the user picked for a hex diameter. Go ahead and drop that in, and now we can actually see what that value is. All right, so that looks good. I want the ability to drive a material for this. So if I use my list box, call this socket material. This is where I was talking about where space will not be accepted. So I'm trying to hit space here. It's only looking for a single entrance. But when I hit return, every capital, so before every capital letter, a space is generated. So DriveWorks knows what you're trying to do, but in order for it to run its rules, it has to look at it as a single entry. So for our socket material, we want some items. So back over on our right side, we are going to generate a rule for the items that populate the socket material. And all I want is a list. So inside our builder, we have functions, any quick text if we're reusing stuff frequently, like I use suppress and unsuppress frequently. You have options to go quick text there. For this function, I want a list. And in that list, I'm going to be able to drive, we'll use steel, we'll make an iron, and a brass fitting for this. So I type those in, and what DriveWorks does is generate a rule for this. So I now know that these are my three options. I click OK, and with that, I now have a populated socket material. The last thing I would like to do is just kind of give a summary of what this part is. So again, I'm going to use label and call this a summary box. So all this is a text box, but I get to drive the text inside of it. So for this, I want to let the customer know that you are creating we'll tell them that, and you'll see what our results looking like. So this is what we'll display on the form, that you are creating we'll add the diameter to let them know what size. So they're creating this socket made of, and then we'll add that material choice that they selected. So looking at this, you are creating a 0.375 socket made of steel. You'll notice my background turned green. If there's an error in there, the background will be orange or red. So when it's green, it's happy. I can click OK. And with that, I generated this nice little note saying what the user is creating. So that looks good, except I have, back in my model rules, I have all these dimensions that need driving, and the information that user just gave me isn't enough to do that. So luckily, I have the ability to create a table. So just a simple table here that I dropped in earlier that has our standards. So every socket, depending on that initial size of the hex, has a specific depth, square size, square depth, and a connector size. So using a table, we can now use all the information inside of here to drive our configurations inside DriveWorks and inside of SolidWorks. So that's how we're going to generate our part. So we have this table defined. Just going to click OK and go back to our model rules and then start using that table to pick some of these dimensions up. So the easiest one to start with here is our hex diameter, because that's what the user is starting us off with. So we're going to click Build. And from our controls window here, we're just going to double-click hex diameter, and that value is now set. So you'll see our value is whatever the user is choosing. For our depth, or actually for our socket depth, we want to use our table. So if you've ever used Excel equations, DriveWorks works very similar to that. It even has a VLOOKUP. So what we're going to look for in our left column is our hex diameter, which sets off all our rules. We're looking in our socket info table, and we want the depth of the socket. When I click Finish, I generate a rule saying we're doing a lookup on a specific diameter, and then we're pulling that from column 2, which was our depth in the table. So I click that. It does the lookup. 0.5 is the return for this type of hex diameter. I can now use that information to actually drive my next hex depth. So I want my hex depth to be about a quarter, half. So half of my total depth. So I'm going to reuse that VLOOKUP value. So VLOOKUP hex diameter, the depth, and an exact match. And all I want to do is divide that by 2. So now I know my hex cut will go halfway through whatever the depth is of that part. So I have a half-inch part, and I'm cutting down a quarter of an inch. So that looks pretty good. My socket diameter. So now this is the diameter of the complete part. I want to make sure that my hex cut can fit inside of my diameter. So I'm going to use that initial hex diameter to drive a larger diameter around it. So if I just add 0.35 inches to this, I'm pretty sure I'll be safe when it comes to cutting out any size hex. So again, add that. Just a simple equation. Still a lot like Excel, where we're using variables and numbers to actually drive more values. Our fillets we'll get into in a second. Our connector diameter is pulled straight from the table, so we'll do another VLOOKUP for that. VLOOKUP, still basing it on the hex diameter. For this one, we want our connector size, an exact match, finish. We'll let it self-generate and click OK. So we now know our connector diameter is 0.09. For the square depth, this is our final one pulling off the table. Last time we'll look at our VLOOKUP. This one we want square height, exact, finish. All right. For our square length and our square width, we know these are the same values because they're square. So instead of going to the VLOOKUP twice, what I can do is generate a variable for this. So I can add a new variable under our data and rules stage and just call this square length. Again, I'm going to drive this similar to how I was before, but because I'm using it more than once, it'll save me time to reuse a variable versus keep creating identical equations. This is square size, an exact match, finish. So my resultant is a tenth. That looks good. I can come back into my model rules and use this new variable, which I was in controls before, I'm now in variables, and let that drive both my square width and my square length. So a little bit quicker than retyping a formula. The last things here is an inner and outer fillet. So as I was experimenting with this, I realized I need a when I shrink down my socket to a quarter inch, my fillets no longer work as they're defined. So a 1-inch fillet on a quarter-inch socket just isn't going to work. So we have to drive those fillet sizes. So for our outer fillet, which is on the full socket, we're going to create an if statement. So I'm going to keep saying, like Excel, we're going to generate an if statement that's going to look at two values, or look at an equation. If it's true, it's going to do one thing. If it's false, it's going to do another thing. So for this if statement, we're going to say if the hex size, back in our control, so if the hex diameter is less than 0.6, then we want our fillet size to be 0.01. If it's greater than 0.06, though, or 0.6, we want it to go up to 0.04. So click OK. Oops, I jumped the gun there. I had to hit finish first. So if hex diameter is less than 0.6, we want it to be 0.1, otherwise will be 0.4. Click Finish, let it generate the rule for me, and now I can click OK. So for our current example, our hex set is 0.375, so the if statement is going to return a 0.1 value. Now for our inner fillet, we're again going to build an if statement. Diameter 7.6. Once we're in 0.01, otherwise 0.04. Finish. Great. So for my outer fillet value, this should be 0.2. Great. Alrighty. So these look like I'm complete here. I have all my categories filled out except for my material. So instead of a dimension, the type here is a custom property. So let me double click on my custom property, and all I'm going to do is I'm going to use the user value, so steel, brass, or iron, but I'm going to tie it to a SolidWorks material. So all DriveWorks is looking to use is that name in SolidWorks for a material. So I'm just going to come out and type my if statement instead of using the if statement generator and say if the socket material, let me double click here, if the socket material is equal to steel, so that's what the user generated or chose, then I want SolidWorks to use ASAI 1020 steel. Otherwise, so this is if it's false, I'm going to do a nested if statement now. So otherwise, if the socket material equals iron, I want to use gray cast iron. And all the material names are right in SolidWorks. You just got to pretty much copy and paste them. So now I'm saying if it's not steel and if it's not iron, then I know my last one is going to be brass. We only gave the user three choices. So I close out my parentheses, I get a green window, we're good to go. So now we're looking pretty good. I can exit out of here, and all I have to do is save my project back in DriveWorks Solo. So now I'm back in SolidWorks, I'm outside of my designer, and there's a Run Project option. So I'm going to click this, and we'll see that my form that we created first, I now can start driving this part. So I'm going to create a 1-inch iron socket and click a preview window. So this blue box is our preview. So it kind of gives me a warm, fuzzy feeling if what I'm creating is correct or not. And with that, we can do a quick measurement just to verify that, yes, this is 1 inch. If I click on the right things. There to there. Of course, I got to use the diameter. So here to here. We do have 1 inch. So we're confirmed there, and you'll see, based on our materials, that we're using iron. If I want to make a change, so if I'm not happy with that look, I can come back in and quickly get rid of my measuring. Quickly change the material to brass, reduce the size of it. So everything is being driven. So that's a pretty easy way to create multiple configurations based on a table. And you don't have to know SolidWorks to be able to do this. All you're doing is selecting what you need and what you want and letting SolidWorks drive the model for you. All right. Now I've created my part. I actually want to go ahead and put that into an assembly. So that's going to be our next step here. So assembly creation. Capture is going to work identical to how we captured that part in SolidWorks, except now we're going to have multiple part files being driven. And we have the ability to drive those dimensions, so multiple dimensions, using a single input. So I can now use that hex size value from our first socket and actually drive handle dimensions based on that input. We're going to go into some more detailed form creation because we need to get all the specifics of a configuration. And we have the ability to suppress and unsuppress parts and features in an assembly. We're going to go in and replace. So we're going to make a our hex head into a star head, and vice versa. So we'll have a couple different configurations that we can drive inside the assembly. All right, so back in. So now I left my initial socket part, and now I'm in a ratchet assembly here. So we're in a ratchet set assembly. We're looking at a star head connected. It's already mated up, so we have 3 mates going on here to connect these 2 parts together. But you'll notice when I'm in my assembly view, I don't have any dimensions or features. That's because all of them are being driven individually. So I have an individual part for the handle, which has dimensions that can be driven. If I go back to my captured models, I also have my star head, which has its own dimensions that can be driven. So these live isolated from the assembly, and that's where all these are getting driven. But when they get mated together and they live together in this captured model, they can be driven together. You'll also notice under my captured model that socket head that we created, so my hex head that we just did, is also in here. And I'll go into some details on what we're doing with that socket head. It's going to end up being a replacement model, so we can swap between a star and a hex fitting. The last thing in here, which we'll get to, is a drawing view of this ratchet set. So once we're wrapped up with our assembly, I'll go in and talk about how to drive drawings as well. All right. Everything else here looks good. All right, we can go into our designer now. So, like I was saying, our form design gets a lot more detailed now that we have other parts and components that are getting driven. Let me just click our test button and we can play around. So we have a lot more details now going into our summary. But our hex size stays the same. So we still have a slide bar. And you'll watch this number down here update as we slide it. What we also have is our handle properties. So we can pick and choose which side we want, what size we want our handle. We can also pick and choose if we don't want a handle. So say you have a customer that's already purchased a part and all they're looking for is the socket. So they already own the handle, they need a new socket size. They can come in here and say, nope, I already got the handle, let's turn that off, and we'll just look at our hex head. We're also now driving color. So like how we did material earlier, we're going to get some color properties here. Similarly, if the customer already has a socket set but needs a new handle, they can come in here and turn off the socket. So now they're just looking at a 10-inch long ratchet with a medium fitting. So they're just looking at the handle now. Another option box here is the ability to go between star and hex fittings, and still they have the ability to choose their socket material. The final thing that will come into handy when we're doing a quote is some quantity numbers. So using a spin box here, we have the ability to go anywhere with a quantity starting at 1. So 1's always going to be the minimum. All right, this looks pretty good. Just quickly looking at the behavior features of each of these options. So in our form designer, we have all these options up here. A checkbox is what we use for the handle. So all this is doing is returning a true or a false result. And that can be used in our model rules to say what we want to show or hide based on the true or false. We have a numeric text box, and that's giving a value with a minimum and a maximum. And if the user goes outside of that minimum or maximum, we have the ability to draw or create an error. So you'll see this error says if the user goes below 6 or types of value below 6 or above 13, we want to let them know that, hey, that's not a configurable size. So we give them an error result saying, please enter a handle size between 6 and 13. Our color, this whole table in here, so you can see we have a lot of colors to choose from. This table is being driven by another table. So if we look into here, I'm using a VLOOKUP table, or I'm using a VLOOKUP to call out all the colors that live inside of a table called colors. Colors are driven by an RGB value, so our red, green, blue is going to dictate what color is displayed on the screen. All right. A combo box, an option box allows the user to choose one, so they must choose one. And again, it's just being populated by a list. So I'm telling it to either show or hide, and the outcome of that combo box or option box is going to dictate what is actually visible on the screen. Again, another option box and the list box that we played with. This is just a note, and our final one is a spin box. So this we have the ability to declare a minimum and a maximum as well as an increment. All right, so that looks pretty good. When we go into our variables, I did create some. We'll go into this a little bit more. Yeah, we'll go into this. A lot of these are due to our quote that it can be generated. Right, we did our tables. They're still the same. All right. So now when I come into my model rules, because I have an assembly with a replacement part, I have a lot more options that I'm able to edit. So as I turn each of these on, I can see that my star head has dimensions that are being driven, as well as our material properties. I also have a socket head, which is that replacement part that we created earlier. So we also have the ability to play with this. So what I want to do now is let the user choose. So I want to say, if the user says, hey, I'm not using a star head, I want to use a hex head, we actually go in and replace that model. So using our star head part, the actual component here, I'm going to generate a new rule. So I want to say if, we'll build this one up. So if the socket type, actually first things first, if the socket is visible, so if the customer actually needs a socket, so if this equals show, we'll start with that and build it from. So if socket visible equals show, that means they need it. And then I want to say if they are choosing the star fitting. So if socket type equals star. Let's get a bracket in there. So red text and red background mean bad. Orange means you're working. So if you have red, it's usually a bracket or a typo. Easy enough to fix. So if that's the case, then I want to use that part. So DW specification just means, yep, you're good to move forward. We placed a label on this part. You can go ahead and use it. If it doesn't equal star, then I want to actually look into swapping this out. So it's definitely a show, but it's not a star. So now I need a new if statement here to say if socket type equals hex, which in our case, it does currently equal hex. So now if it's equal in hex, we want to replace that model. So I have a couple more controls up here. Now I'm going to go into components. And what I want to do is I want to replace it with that socket head that we created earlier. Oops. Put it in a bad spot here. Let me get to the end. So if it equals hex, then I want to replace it with the socket head. Otherwise, I want to delete that socket head. I don't want to see it. So close that up. And finally, if it doesn't equal show, so if we're saying the socket isn't visible, we just want to delete it. Under our values, it kind of gives you a guideline of what we're going to do. So right now, our socket type return is a hex. So we have a hex fitting. our visibility is show, so we definitely have a fitting on here. That means we're going to replace our current star fitting with a socket head. So this rule looks pretty good. All right. I don't think we have anything else missing as far as our rules go. We can go ahead and play with this one now. So I'm going to close out of here. I'm going to save my project, and I'm actually going to run it. So we now see our form over on the right side, and I can start moving some things around. I do want a handle, I want a hex head, and quantity is okay. So I'm going to preview it, and we're going to let SolidWorks actually build this model using the inputs from DriveWorks. So you'll see we got so close. So even though my handle color is called out for fire brick, it's clearly not changing that. So I missed a rule in here. My socket head looks good though. I was able to get a hex head with the correct mating, and I don't have any errors. So if I drop my handle size down to 5, which it's looking for 6, you'll see that I'll get a task that I need to complete before I can move forward. So it's going to say, please pick a number between 6 and 13. So let me put 10 back in there. All right, before I go further, I want to make sure that my color is drawn for there. So I'm just going to cancel, close out of this model, and open this back up. So I had filtered out just for my socket types. Now I want my handle, and I'll see that I'm missing a custom property here for DW color. So now what I want to do is a VLOOKUP based on that color table. So back into my functions, VLOOKUP, and I'm looking up the name that the person chose. So in this case, we're looking up fire brick. Now I have to choose between the two tables that I have available to me. I either have socket dimensions, but I want my colors table, and it's going to be an exact match. So I'll finish this, generate it. Looks okay. Actually, I want my second column, so I want the RGB value for this one. So fire brick, so my result is now an RGB value. That looks good. All right, let's see if that did the trick. I'm going to save again, run it, and let's see if we get fire brick this time. Perfect. Now we have a colored handle here with a brass top. Everything looks pretty good. So now as I'm playing with it as a customer, I can say, all right, I want the biggest size. I want to max out here. Maybe put a star head on it. Let's see what that looks like. And every configuration will now just be easily drivable. We'll see that we've updated our size here. We can also go in and start hiding some options. So if I hide my socket, all I'm going to end up with is a handle with a large fitting here, which is based on the square size. So that looks cool. If I want to hide my handle, but bring back my socket, maybe I want to hex and iron, I can also do that. So now our handle's hidden. Now I forgot to play with my material properties. But we can also hide our handle. What is good to find out while we're doing this is we're going through our configurations. I want a star fitting on the smallest size. And then as it's crunching, I start to hear some error noises in the background. So clearly, this size was not a fan of our star head. Let me try the next size up and generate that model and see if that one's okay. Yep. So at the 1/4 inch size, the star head overlaps itself and it cannot be created. So just like when we did an error for the handle size, we want to be able to tell the end customer saying, hey, I'm sorry, but that size doesn't work for this. So going back to our slide rule, we can add an error result. So we're going to build a rule saying if the socket type is star, if socket type equals star, and our hex size is, there it is, equals 0.25, which is that small size where it crashed, then we want to let them know that the star socket does not come in that size. Otherwise, they're good to move forward, and we won't display an error. So let's go back into our form and see how that error message works. So it was hex size equals 1/4 inch. While we're under the star configuration, you'll see we get a task down here saying star socket does not come in that size. If I increment the size, it goes away. If I flip to my hex size, it goes away. So a nice little indicator there to say, hey, take a step back and let's look at this design. All right. So that's pretty cool information on an assembly that can be driven completely while changing out parts. So let's swap in a hex fixture there. So we've taken a star driver, said, nope, you're no longer a star driver, you're now a hex driver, and have the ability to change that in pretty much live time without changing any configuration tables or anything else. We're doing it right out of this form designer. All right. We covered that. The next thing I want to talk about is the drawing creation. So it's really great that we can make all these different configurations, but the next step is getting those documented and manufacturable. So what we have the ability to do inside of drawing is control drawing numbers, descriptions, as well as any views and where they show up on the page and if they need to show up on the page. So if I'm the customer and I only need a socket head, I don't want to see the handle in my drawing. I just want that socket head. Back into SolidWorks, we'll look at the base drawing. So under our captured models, I showed you earlier that we have a ratchet set drawing. So I'm going to open this up. And this is the drawing that's being driven. So our base drawing has an isometric view of our ratchet set. It has just the handle with a couple dimensions that were driven. And it also has our star head. So a side view, bottom view, and a top view. I'm also just calling out some specific titles. So description is going to go under our title block, our drawing number is going to be driven, and our sheet size is going to be driven. Now, like I was saying, if I'm a customer and I only need a socket head or I only need a handle, I don't want this entire drawing. So I also created a couple sheets based on just the socket head with the call out for material and the sheet just for the handle with a color call out. Also, we're going to have a description and a call out for that part number. So that looks okay. I'm just going to go look at my form to see how I'm driving this. So back into my, my designer. For this one, we only want to look at our drawing. So when we're driving a drawing, we get a new view here, which shows us each sheet and the drawing views on that sheet. Up top, we can say what drawing views, let me filter these. We have the ability to say which sheets we want to view, which drawing views we want to view, any scales of those drawings. So here's all our view states. Get a little more information here. All right. So drawing view number 2 is this handle. As I find it here, drawing view 2. So I want that unsuppressed if I'm using the whole ratchet assembly. So again, you'll see if you want a view to show, you unsuppress it. If you don't want it to show, go ahead and suppress it. And that rule is easiest, typing unsuppress in quotes or delete or suppress if you don't want it. What I did do in order to get this to work is our sheet state. So what I showed you in the captured model is 3 different sheets. In order to do that, I had to create a couple options. So the first sheet had a socket drawing and a handle drawing with the isometric view. So I called that option 1, which meant the socket view was turned to true, or to show, and the handle checkbox was checked. If that's not the case, and then we go to option 2, or option 3, which was the handle check part was unchecked, but the socket was turned to show. Socket visibility was on show. Then we're going to show our socket drawing, which was the second sheet. Otherwise, we're going to delete the sheet and not send it to the customer because they don't need it. They already have it documented in sheet A. Similarly, for the third sheet, option 2 was just the handle. We're only going to show the handle drawing. Otherwise, we're going to delete that. So we have that. Some other things that were driven here is the material callouts. So anytime we show the socket, we had a note with a callout for the type of material. So again, if the socket is turned to show, then we're going to return what the customer chose for the socket material. Otherwise, we're going to delete that note. Drawing number based on the option is going to be lunch and learn with a increasing number. So every time I generate a new drawing, that number is going to increment by 1, and just a call out for wrench. Callouts. Final is the description, which I created a variable for. So let's go look at our variable for description. So this one's kind of long because there's many options to create this final description. So I'm saying if the handle is turned to true, then we're going to return the arm size. We're going to look up the call out for that size, if it's a medium or a large. Then we're going to look and see. So option 1 was if the handle's on and we're showing the top, then we're going to say it's also with, let me make this longer, the size of the socket and the type of socket head that it is. So a couple different options there to drive that rule. Let's go ahead and play with it now. We'll save this up and run it. All right. So again, I have to create my part. Now we'll get a star. We're going to show this. We'll change the color up. Ooh, hot pink. And we'll do steel. Now I'm going to preview my part first to make sure, yep, this is the assembly that I want to create. So I got my pink handle with the steel. Looks pretty good. Actually, I want a little bit bigger size, and we'll change up our handle color. It's too pink for me. Let's try that. So we got green with the biggest top. Looks good. So now the next option here, next to preview, is our drawings tab. So we click on drawings, and what it's doing is going through those 3 drawings that we captured and picking and choosing based on the rules which one it's going to display. So for this case, it's option 1 because our handle's turned on and our socket's turned on, and it's generating this drawing. Because I didn't do all the alignment text, there's some cleanup to do, but this can also be automated based on the size of the drawing. But you'll see we get a call out for our hex with the material, gets a call out for the color. This value of our handle is matching the handle size that we inputted, and our star size is matching our hex size. So 1.375 gets rounded up to 1.38. Finally, we're getting that title, which was driven by the variable, as well as our call out. So this is the 99th time that I've made a socket or a wrench drawing, and that gets called out here. So say I do all this and I realize, oh, I already own this handle. I don't really need it anymore. Inside the same session, so I'm still in drawing 99, I can go back, regenerate this star head, and create a new drawing. And again, DriveWorks is going to go through and say, all right, so now we're on to option 2, where we don't have a handle, we just have our hex head, and it will go ahead and create that hex head drawing for us. We still have the call out for steel, but now we lose all that handle detail. We keep our drawing number of 99, but now we have a call out for socket, and our description updates automatically. Same goes if I hide my socket and only want to create a handle, still in this nice long green color. I can generate my handle. I can create a drawing. We'll go through and say, yep, this is the one you wanted to create. Let me position these where you told me to. And we get this call out with just our ratchet and a call for the handle. Just realized I'm running a little low on time here, so I'll go to quote creation quickly. DriveWorks gives you the ability to self-generate a quote document where you can call out quantities, descriptions of items, the cost of items, even terms, so shipping terms, job numbers, all that detail. So quickly, let me cancel out of this and just show you how I can generate a quote. So going back into our designer, we have this Documents tab. And in here you can add a bill of materials, a quote, or a cover letter. So for this one I created a ratchet quote. Under our variables, all those items for the quote come. So some of the common ones are the company name, company location, and phone number, any of those terms and sales tax that are consistent, or it can even be driven. So the date created is just the text output of today, and then you can add a buffer on there for when it expires or when it's due. We also have line items. So every line item in here, if we want to separate the socket from the handle, we can make each of those a line item and call them out. That looks good. What I do want to do is give a price based on, shrink that up, based on the type of material that we're using. So this rule here says if the customer chooses a steel socket, we're going to multiply it by 1. If it's an iron, we're going to multiply it by 1.2. If it's brass, we're going to multiply it by 1.4. So now we even have custom pricing coming out based on the size of the handle, small, medium, and large, and the size of the socket. So small, medium, and large, again, each have their own multiplier. With this information, I can drive a new model. So we'll do a large model in iron, and we'll do brass. We'll go for the expensive one. We'll do a star fitting with 10. So I'll drive this model. Let SolidWorks generate it for me. It's a pretty boring color, but we'll go forward with it. And then the final one, so next to our drawings, we now have a Documents tab. And for this part file, I have a ratchet quote. And hopefully you guys can see this. So in our ratchet quote, we have our first line item is just the socket. So we're using 1 1/8 brass star socket, which the price equation that we generated turns out to be $7. And then we have a Gainsborough large handle, which costs $3. It'll sum it up. So now with sales tax, it costs $10.90, and that can go straight out to a customer with doing very little work on your end. If we do want to tweak the quantity, change the color. Ivory's going to be boring too. There we go, yellow. We can again generate the model, create the document for it, and have a quote at our fingertips in a very quick matter. So now our quantity has gone up, our multiplier has gone up, and now we're at $32 per ratchet set. All right, next steps. Hopefully this lunch and learn has been informative and inspired you to go out and try DriveWorks. It is a very useful tool, especially if you're doing designs that are similar but need that little bit of customization. So first step, I'd say use DriveWorks Express. It lives right inside Tools, DriveWorks Express. It'll live over here in your task panel. Next step would be to look at DriveWorks Solo out on the web. So simple website, and right on there, right on the home page of DriveWorks Solo is a 30-day free trial. So you're having some success in Express and want to take that next step, I'd highly recommend going for a DriveWorks Solo 30-day trial. Next steps after that were DriveWorks Pro Live Autopilot. And an example of that, again, on their website, there's a configuremyproduct.com where you can actually go onto a website and start configuring some models live time right on the web. You actually see your 3D model being generated based on the dimensions you're driving in. So a fun site to play with as you're figuring out what DriveWorks can do for you. So we got that. Finally, we got some upcoming events, webinars, test drives, the morning show, all can be found on our CAD Dimensions website. The next Lunch and Learn is next week on SolidWorks display settings. We have a morning show next Friday, hosted by Kevin and Lars. And then next month we have a Lunch and Learn on EPDM templates. In case you missed anything, you can go onto our website and connect with us, Facebook, Twitter, YouTube, as well as our new blog, constantly updating. We got about 3 posts a week at this point, so please go check out the CAD Dimensions blog. A lot of good information going out there. As always, if you have any questions, feel free to email me. I'm not even sure I put my email on this presentation. You can always email me, tdelora@caddimensions.com. Give us a call, and I really appreciate your time today. Please send any feedback or questions.